7.2 scientific notation. We're going to be converting between standard and scientific notation. Standard being like your normal, numbers like 5006 to a scientific notation will look like 5.006 times 10 to the third power. Yeah, third power. All right, and then operations in scientific notation we'll be doing also. All right, so let's get started. Writing numbers in scientific notation. Now, you may have used this in your science classes, and if you haven't, you will be. Scientific notation is a way of writing extremely large or extremely small small numbers as a product of some power of 10. Right? So the form of all numbers in scientific notation is a times 10 to some power n, where n is an integer and it has to be greater than 1 or equal to 1, greater than or equal to 1, but less than 10, right? Make sure that there is a single digit in front of the decimal point. It cannot be 0. And then we must move the decimal left or right in order to achieve that. And you'll see what we're talking about. Negative powers of 10 are very, very, very small numbers. Okay, positive powers of 10s are very large numbers. So when you're working with negative powers, negative exponents, remember they became fractions before, they're smaller than 1. Fractions are smaller than 1. So that's going to be the same situation. You're going to have a very, very, very small number. Scientific notation is extremely useful when you're converting units of measure, including particularly useful in science. So that's where it gets its name. All right, so when we're doing this, let's first practice transforming numbers in scientific notation to excuse me, I'm getting this backwards. Transforming numbers in standard notation to scientific notation. Here is an extremely small number, 0.000041, and we want to make it into scientific. So we have to have a number in front of the decimal that's bigger than 0. So we need to move it until we find one, until it passes that 4. That's the first number that's bigger than 0 in this number. So we're going to move it that direction so that we can get that. So it's going to go this direction, and then we'll put a decimal right there between the 4 and the 1. We want one number in front of the decimal, and it has to be bigger than 0. So we write 4.1. Now you don't just cut off all the rest of the numbers. You put 4.1. Unless it's zeros, you can't cut them off. So it's 4.1 times 10, which is our base, to the, and we went, and this is a small number, so it will be a negative exponent. So we went how many places? 1, 2, 3, 4, 5. So we went smaller. It's a small number, so it is going to be to the negative 5. Okay, so just go back and check what you're doing when you're finished to see if it makes sense. We have a small number. It has to have a negative exponent. All right, then we have a large number, 8,002,000, and we want to shift that into scientific notation. So remember, where's the decimal in this kind of number? The decimal is always back here at the back, okay, right here. So remember, if there's no decimal in the problem, it's at the back. It's like money. All right, so we must shift it to the left in order to get to a number. There's only one number in front of the in front of the decimal point that's bigger than 0. We can't stop at 2 because now we have, it's really going to be then 8,002 point something. That's still not in scientific notation. We have to go till it's just one number in front of the decimal. So when we move it all the way over to the 8, it's going to be 8.002. You cannot cut off if there's other numbers other than 0. You have to go until you get to a point where there's nothing but zeros left, and then you can cut those off. All right, so it's 8.002 times 10 to, that's always going to be the base, to the 6th power because we went 6 places this way, and it's a large number, so it has to be a positive exponent. Okay? Right? Now, we're going from scientific to standard. So remember, if it's a negative exponent, it's going to be a very small number. So you want to go and make it smaller. So 8.6 making it smaller means you have to go this direction, 5 places. So you have to count every place you move. So that's 1, 2, 3, 4, and put a dot. So if you don't have any more spaces, you have to make placeholders and put a 0 there. Okay? So you're going to shift and make placeholders, and every time you have a little placeholder, you put a 0. So this will become 0.000086, which is a very small number, smaller than 1. And if it helps you to put a 0 right here, so that you'll know that it's a smaller number, that's fine, okay? But that is going to be your final answer. This is 8.6 times 10 to the negative 5 is really 0.000086. Okay? Here's another example, 9.31 times 10 to the 5. That's positive, so that means it's going to get bigger. So if I'm going to get bigger than 9.31, I'm going to go to the right and make it bigger. Because if I move, every time I move, it's getting bigger and bigger number. If I move it once, it's 93 point something. If I move it twice, it's 931. So you're going to move it 5 places. So that's 1, 2, and then we have to add 3 zeros, 4, 5, 3, 4, 5, in order to get the 5 places. Okay, moving it to get your 5 places, and you put zeros in your placeholders. Then the decimal will end up at the very end, and you will have 931,000. You don't have to put the 0.0 on the end if you don't want to, but if you do, that's fine. And that's when it will become. Just double check your work. I have a positive exponent. That means it's a bigger number than what I had. Okay. All right. Now we're going to use our properties that we learned for exponents. Okay. This is an expression, 3.1 times 10 to the 4 times 4 times 10 to the negative 8. Okay, remember, this is a big number, and this is a big number. You can multiply those. You get 12.4. And then remember, when you're multiplying exponents, you add them. So it's 10 to the 4 plus a negative 8, which makes a negative 4. Okay, and then notice, though, this is not in scientific notation because there's 2 numbers in front of the decimal. You must check your answers, especially when you're doing multiplication of 2 scientific notation expressions or division. So check it at the end, and then you have to move it. But let me show you. All of this we can do in our calculator, and I'll show you how to get all this so it's not a problem. The only thing, not only do you need to come into the class and you need to clear your calculator, and you also need to turn your diagnostic on, but you also now need to go into your calculator and put it in scientific notation, okay? And you can take it out of scientific notation or put it back in, depending on what you're doing. I would not put it in scientific notation until I am working in scientific notation, okay, because it can mess up your answers for other things. So once you're finished, you could clear your calculator and reset it, and go back and put your diagnostic back on, or you can learn how just to turn it off. So I'm going to show you how to do that. So when we want to turn it on, you're going to hit second and then the mode button right next to it. Second, mode. Why is my mode not working? There you go. All right, so second mode, and you'll get this screen. And then it's got all these things. You've seen this before because we've done a couple things, I think, in this window. But you notice right now it's got normal. You want to scroll over to where it says SCI, which is scientific. Okay, once it's blinking on scientific, hit enter. Okay, and then hit second mode again, and it goes back to your working window. Okay, so now it's in scientific notation. Now, you want to type this in just as you see with those parentheses. And we've practiced using parentheses a lot this year for this reason. The more you do it. All right, now I'm going to do 3.1. I'm not going to hit the times button. I'm going to show you a shortcut, okay? This you'll use if you go on to chemistry. The chemistry teachers are going to love you because you're going to already know how to do this. But you're going to push a button that's going to take care of this times 10 part all in one stroke. So you're going to go second, and this EE button right here at the comma, push that. EE button means times 10. Times 10, and then all we're going to do is put in the exponent. So this takes care of times 10, and now we're going to put to the, and this is 4. I don't have to hit the up button or anything. I just hit second, EE, and it does it for me, and close it off. And then do the other one, so that's going to be 4, second, EE, and then -8. A lot less typing than if you had to do it the other way, okay? So 3.1, second, EE, 4, which is the exponent, and then 4, second, EE, and then the exponent, which is -8, and hit enter. And notice it will give me 1.24e to the -3, which is the E stands for times 10 to the -3 exponent, okay? So if you just remember, when you see that E, that means, I'm going to write right here, E means times 10 raised to something. Okay, and all we're doing is typing in the exponent. Okay, so it's a very, very easy way of doing it. Now watch, if I wanted to go back and type it in the old school way, look at what all I have to do. 3.1 times 10 raised to the 4. Cut that off. Now I get to do the other one. 4 times 10 raised to the -8. There's a whole lot more time. And if you're doing an SAT or ACT type test where it's time, you don't want to be wasting time pushing all these extra buttons. It'll give you the same answer, but look at all I had to do. Okay, so if you just remember, instead of the times 10 and the up button, it takes care of 3 strokes with one little push of second EE. Okay, now same with your division problem right here. The only thing you must remember is that this is an expression, and expressions means that it needs to go in parentheses, okay? It needs to go in parentheses and then hit division, or you will have a mess. So watch what I do. Okay, I'm going to clear that out. All right, so I'm going to put a parenthesis 1.08 second EE 11. Close it off, divide. Parenthesis 5.4 second EE 5. Okay, close it off. Hit enter. That says 2E5, which translates to 2.0 times 10 to the 5. Okay, which is what you got right here. Now, you can do it the old school way where you divide 1.08 divided by 5.4, you get 0.2. And then 1011 subtract 5 will give you 10.6. But then this is not in scientific notation, and then you have to fix that. So you can do it that way. I think using the calculator is much, much faster. If you have a problem like this, say you get this and you want to do it every way, but then you get confused at this part, you can put that in your calculator. 0.2 second E6, okay, and hit enter, and it'll correct it for you. Okay, if you get to that point and you don't know what to do, you can always type it in. It will fix it for you. Now, everything that you do will be in scientific notation. You know, when you want to do 16 divided by 5. It's going to give you scientific notation every time. So you don't want that unless you're doing scientific notation on a test. Okay, especially during the SOLs, you do not want this on every time. It will get really confusing and aggravating for you. So if you want to take it off or take it on, put it on, you go to second mode. Why didn't I? Right, second mode, and see where it was in scientific notation. I'll go back over to normal. Back over to normal. Why is it not moving? Okay, back to normal, hit enter. And now it's highlighted and then just second quit. Okay, so now when I do 16 divided by 5, it'll give me 3.2 and no scientific notation stuff. So you need to be able to go back and forth with the scientific notation. I would not leave that on the entire time you're in class. Diagnostic on and clearing your calculator every time, yes. But as far as scientific notation, I would only have it on scientific notation when I was doing a scientific notation problem. And then I would immediately go back and take it off. Okay? All right, so I believe that is all that's on this section. Yep. So if you have any questions, come see me and we can work with the calculator. But this section's pretty easy since you do have the use of the calculator. All right, see you in class.